right. Yeah, thank you for tuning into this webinar on how to save energy this summer. So a little bit about me. My name's Arky and I work at Sapien. It's a company that I started up with a friend of mine a few years ago. We were both studying engineering at the time and we're both very passionate about sustainability and energy efficiency. And we just kind of sat down one summer and had a bit of a brainstorm about how we can get involved in that space. We're both kind of a little bit entrepreneurial minded as well. And that was how Sapien was born. And so it's a business that helps people make their homes more energy efficient. And principally we started off doing draft proofing because it's a really accessible way to improve the performance of your home that anyone can do, which is great news for all of you guys. And we've kind of just been building on that over time and the response has been really good. So that's how I sort of got into this space. So the agenda for today, we're going to chat quickly about how weather has been changing in Victoria over the last few years. We're also going to do a bit of an overview on the energy efficient home retrofit journey. So the main steps to building a house that's more energy efficient. We're also going to chat a little bit about indoor air quality, which is becoming more pertinent with extreme weather events such as bushfires or thunderstorm asthma. And then at the end, we'll go through a couple of draft proofing DIY tips and tricks, so stuff that we've learned over the years that we'd love to share with you guys. And then we'll have a bit of a Q&A at the end for any questions you might have. So I've pulled these lovely graphs from the BOM website, and these show temperature anomalies for summer in Victoria from 1910 to today. So on the left, we've got the average temperature and we can see how it's steadily increasing over the last few years. And that black line there is the rolling average. And over on the right, we've got the maximum summer temperature anomaly. So you can see in particular, the summer of 2018, 2019 was had a very hot day. So we're getting higher average and higher maximum temperatures and it's still trending upwards. So these are sort of great reasons to start to think about how to prepare your home as our summers are getting hotter. We're having more heat waves and more extreme weather events. And we're also starting to get a more consistently higher severity bushfire season, which is another consideration that has entered all of our lives, in particular in January of this year. So the energy efficient home retrofit journey is made up of about kind of 8 key steps. At the start of the journey is sort of the more passive principles, which we'll get into a bit in this presentation, like draft proofing, lighting, good insulations, high performance windows. And then it's kind of more the energy usage and so appliances and cooking, heating and cooling and hot water. And then the kind of last step in the journey is solar power. So how do we offset the energy that we're still using to be more sustainable or reduce our bills even further. So you don't have to strictly follow that order. If you are looking at going on this journey, you can do bits and pieces, but if you can, it is generally a good idea because the items that are earlier on in the journey kind of treat the problem at the source by reducing our energy consumption or energy requirement to begin with. And then later down the journey, this has run-on effects, particularly with how you might size your solar power system. So why would we begin the energy retrofit journey? Beck touched on a couple of these, which is great. The number one reason we get called out to people's homes to do an audit is to improve thermal comfort. I just thought that was interesting. When we started the business, we really framed it around reducing energy bills, but we found that that was secondary to people's thermal comfort. So a bit of an interesting tidbit there, but that's a great reason to begin the energy retrofit journey, especially as we're spending more time at home now than we ever have before. The second great reason is if you reduce your energy consumption, you're also going to reduce your energy bills. So less money out of pocket is always a great thing. And also as a result of reducing our energy use, we're reducing our carbon footprint, which, yeah, as we all know, climate change is a very pressing issue and every little bit counts in reducing our carbon footprint overall. So draft proofing, the first step in the home energy retrofit process. Air leakage can account for about 15 to 25% of winter heat loss in Aussie homes, and it's also a significant loss of cooling in summer. It's a great place to start. It's one of the kind of lowest cost options to look at in the energy retrofit journey, which is why it's so early on in the piece, and it has long lasting benefits of reducing your energy requirements. There are a couple of other kind of side effects of draft proofing, which are often very beneficial. So if your home fronts onto a sports oval or a busy road, often we find after we've draft proofed a home, it improves the acoustic separation from the outside. So really reduces that incoming noise. The other benefit is it will reduce the ingress of dust and bugs, which is great. And we're also getting a reduced air change rate during high pollution events. So during a bushfire event or a thunderstorm asthma event, we're slowing the rate that outside air can infiltrate into our home, which can be helpful. And we'll talk about this a little bit more at the end in the draft proofing DIY tips and tricks. So the next step in the journey is lighting. And the reason lighting is so early in the home energy retrofit journey is it does have a couple of run-on effects for other items you might want to look at for your home. So principally halogen downlights, which are very common in Australian homes, use a lot more electrical energy than LEDs. So it's always a good idea to replace them with an LED alternative. Beyond that, these fittings are usually ventilated because of the heat that halogen downlights generate. So that's another source of draft. And you really want to maintain kind of separation between your ceiling space and your living space, especially in summer. Your ceiling space can get very, very hot compared to the temperature you would like your living areas to be at. So that's really unwanted air leakage that we have as a result of having downlights, halogen downlights. Then the third reason halogen downlights are bad is they have clearance requirements around them, which must be free from insulation because otherwise it could be a fire hazard. So I've got a little image on the right there, which is a snapshot from the construction code, which shows those clearance requirements that must be free from insulation around a halogen downlight. On the left there, I've also got an image we took with our thermal imaging camera at a home that we audited. And you can see the big temperature difference around that downlight where there's basically an entire panel of insulation missing. Now, this is a pretty big problem because a loss in insulation coverage has a disproportionate negative effect on the performance of the insulation. So say you have a 10% loss in insulation coverage, so you're missing about 10%. The effect isn't a 10% loss in performance. It's around 30 to 50%, depending on what sources you read. So it's really, really important to try to avoid thermal bridging that occurs when you do lose a bit of insulation coverage. So what can we do about it? For renters, replacing the halogen globe with an LED alternative always a great idea. It's going to consume far less energy. If you are a homeowner, it's a good idea to not just stop at the globe, but actually replace the entire fitting. If we replace the halogen downlight with a fully sealed LED fitting, we've dealt with the air leakage that we were getting. And also, depending on the product that you buy or if you can cover it, often these LED fittings can be fully covered over with insulation, which solves that problem. Whereas if you only replace the globe, you still need that clearance requirement, even though it's now an LED alternative. Down the track, someone might change that globe back when it breaks. So you still need that insulation clearance. But if you replace the whole fitting, often you can insulate right over on top of it, which is great. So the next thing to look at is insulation. We've already talked a little bit about how gaps in insulation have a disproportionate effect on its performance or its ability to resist heat movement. So during summer, we get about 25 to 35% of our heat gains through the ceiling. So that's kind of the most important place to look at when we're thinking about insulation. Then we also get about 15 to 25% coming in through the walls and 10 to 20% up through the floor. As you can see on the right there, I've got another thermal imaging shot that we took in a home that had very poor insulation coverage. Unfortunately, this is not a rare occurrence when we're doing audits, and this is often what people's ceilings look like with very patchy insulation, which is unfortunate, but just the reality of most homes that we visit in Victoria. So what can we do? For ceilings, we recommend R5 batts. R is a measurement of the ability of the material to resist heat transfer. So the higher the R value, the less heat is going to transfer through the material. And so R5 in the ceiling, this is a little bit higher than the minimum requirements from the construction code. You can go even higher, so obviously the bigger the better, but you do start to get diminishing returns the higher the R value you go and the more insulation you put in. So R5 is kind of a nice sweet spot where you're really getting a lot of benefit from your insulation, and anything on top of that, while is definitely helpful, you're starting to get a little bit of diminishing return. So R5 is a really kind of happy place for the value of the performance of your ceiling insulation. Wall insulation can be a little bit tricky, but there are service providers on the market that can do blow-in wall insulation, which is a good idea for a retrofit. So essentially it involves cutting kind of a 20 cent or 50 cent size hole in either the plasterboard or weatherboard or even through the brick. There'll be a number of these holes, and then they can blow insulation into the wall cavity to improve the performance of the walls, which is, yeah, always a great idea. There's a couple of tricks for telling if you actually have wall insulation or not. Chances are it probably is either patchy or not there. That's at least from what we have found in our audits. If you have a thermal imaging camera or you want to buy one, you could use that to check out your wall. The only issue here is it'll be good at picking it up if it's really patchy, but if it's non-existent, if there's no insulation, it still might just all come up as one color on a thermal imaging camera shot. So it might be difficult to tell then, but you could maybe compare it to the floor or the ceiling to have a look, but it is a little bit harder. The other way to tell is if you remove a kind of power outlet cover off the wall, and obviously being careful of any kind of cabling, but if you can put your hand in through and feel around in the cavity to see if there's any insulation there, that'll give you an idea of how well insulated your walls are. For underfloor insulation, we recommend R2.5 polyester rolls. The reason we recommend this product is it's comes in long rolls and it's made to a standard size to fit really snugly between floor joists, and then it can be staple gunned in. So it sits in there nice and firmly and snugly and performs really well. There are other ways to do this, but you just need to be careful, say, with other methods of holding the insulation in there. So if you're going with bats and you're using kind of chicken wire or strapping to hold it in, often it pulls away from the underside of the floorboards. And so you start to lose a bit of the performance, or it can even create a home for vermin. So that's typically why we go with these polyester rolls, and they're a very solid product. And we've got an image on the bottom right there of some of those that have been installed. And they're actually a great DIY option as well. You can order these rolls, and there's instructions on how to install them yourself if you want to have a go. You can also get a professional to install them. Typically you need about 400 millimeters clear from the floor to the ground for someone to be able to get in there. But yeah, so that's our piece on insulation. Windows. So once you've looked at the other steps, windows are going to become your biggest source of heat gains in summer or heat loss in winter. So blinds and blockout curtains are always a great idea, and something renters can look at as well. When we're looking at blinds, there are things like the product shown in the image on the left there, where it's a honeycomb blind. So as it opens, it's actually creating an extra layer of insulation with a still air gap, which is going to resist the movement of heat through that window, which is really good. The other thing to consider when you're putting in blinds or looking at different blind options is you want it to be snug to the window frame. If you've got gaps at the top or the bottom or around the sides where air can move, then you're not getting the same benefits of a nice still air gap, which will insulate it a little bit better. So something else to consider there. Obviously during the day, if it's hot, try to block out the sun on the northwesterly or easterly side, depending on the time of day. Another option we can look at is window films. So for hot weather applications, you can get low emissivity films, which are typically always a good option for hot weather. So it will reflect a lot of the sunlight that's trying to enter the home. The only thing to consider here is that it might be a bit of an issue for the neighbors if your windows are too glary or reflective. And also you're going to reduce the amount of sun that comes in during winter months when you actually really want that sun to heat up the house. So you kind of need to weigh up the benefits there. And you do kind of want to be looking for something that's going to provide benefits all year round rather than seasonally, but low emissivity films will work well in hot weather applications. There are some other types of films out there that either improve or reduce the amount of light coming through. But yeah, it's sometimes the value for money proposition isn't there so much with the window film. So it's just important to do your homework and make sure that you're getting a product that's actually going to help you all year round and not just give you a seasonal benefit. So secondary glazing, we've all heard of double glazing, and double glazing is without a doubt a great idea to reduce the amount of heat that's transferring through the windows and improve the performance. But it is very expensive. It's quite a high price point, which often dissuades people from going down that road. So another more cost-effective alternative is secondary glazing. So rather than replacing the glazing units, what this does is it applies an acrylic sheet on the back of the existing glazing with a spacer. So you get the thermal benefit of that still air gap and an extra kind of pane, an extra window pane, without the price point of actually fully replacing the windows with a double glazed alternative. So I think there's a couple of providers out there on the market, and it's a cool option to look at if you want to improve the performance of your windows. If you are looking at replacing the whole window, it's definitely important to consider the window frame. So if you want a metallic finish or an aluminium frame, this is a great conductor of heat, which is a problem for the performance of the window. So you either want to go for a low conductivity option like wood or plastic, or if you do want that aluminium finish, then it should be thermally broken with some wood or plastic inside it. On the right-hand side there, I've got an image of a sample from a sustainability workshop of a very high performance window, probably a little bit overkill for this climate, but I thought it was cool. So I just thought I'd share that. It's just a little triple glazed unit with several rubber seals and a high performance frame. So I thought that was cool. External shading, very important for summer. So one of the easiest things we can do is plant deciduous plants. These are plants that are nice and leafy in the summer, so they provide lots of shading, and then they shed their leaves for winter so that we can let that winter sun come in and heat the home up. So having plants can help us in summer through three kind of different mechanics. The first one is shading, so reducing the amount of sunlight that's hitting the home. The second one is evapotranspiration. So the moisture that's evaporating from the plants will actually reduce the air temperature around them, creating a bit more of a cooler environment. And then the third way they can assist is increased vegetation will slow down gusts of wind around the home. So if there's a really hot northerly wind, having increased vegetation will slow that down and reduce the ability of that hot wind to add heat to the home through convection. For fixed shading or for north-facing windows, it's a good opportunity to capitalize on the different angles of the sun depending on the season. So you can see in the bottom right image there, we've got the summer has a really high angle. The sun has a really high angle in summer and a really low angle in winter. So we can design fixed horizontal shading, so like eaves that jut out horizontally, that's going to let that winter sun in when we want it and block out the summer sun when it's too hot. So that's always a good option there. And you can also do it with kind of louvered shading or slats like we've got in the middle image there. For east and west facing windows, because we've got that sunrise and the sunset, we pretty much always need adjustable vertical shading. So blinds that will go up and down so that we can adjust depending on the time of day. Also, Stonington City Council has been running a My Smart Garden program. If you wanted to maybe say a couple of words about that one, Beck.
Yeah, cool. I'll chime in here. Yeah, we're part of a great gardening program called My Smart Garden, and they actually ran a whole session on basically this exact topic, keeping cool with trees and vines. So it's a whole hour or 90 minutes right on this. So if this is something that you're interested in exploring, I'll share a link with you in this chat and also in the follow-up email. But there's going to be lots of great suggestions for types of plants and time of year to plant and that kind of thing. Yeah, I'll send it through.
Beautiful. Thanks, Beck. All right, so next on the list is cooling or different types of active cooling for the home. So this is a really important one. Heating and cooling accounts for about 40% of household energy use. So it is a big piece of the home energy pie, so to speak. The higher we can tolerate the set point in summer, the less energy our system is going to use. So typically somewhere between 24 and 27 degrees is sort of a fair compromise between thermal comfort inside versus the energy use of the system. Obviously, the closer we have our set point to the outside air condition, then the less hard our air conditioning system is going to have to work. Fans are by far the lowest energy option and should be the first port of call. And you can even get a bowl of ice out of the fridge to get a little bit more juice out of the fan. But yeah, always a great low energy alternative. So there's a whole bunch of different active cooling options, which we're going to have a little look at. obviously number one is fans. Then we have air source heat pumps, or your classic reverse cycle air conditioning. And there's a few different types we're going to talk about. We also have evaporative cooling, which is pretty common in Melbourne. Then there's also ground source heat pumps and geothermal, which are a couple of other options which aren't as common, but we will touch on them briefly. So firstly, we have fans. These are the lowest energy option, but they're also the least effective at keeping you cool if it is very hot. So fans will cool you down, but they won't cool the room down or lower the temperature of the room. So often on the really hot days, if the fan's not going to cut it, we need to look at other active cooling options. So for renters, portable fans are always a great idea. Usually the smaller they are, the less energy they're going to draw. And you can even get little desk fans or USB powered fans, which only draw a couple of watts. So there's a few different alternatives there, which are great for just a little bit of local cooling to keep you comfortable. I also wanted to touch on the kind of Dyson style air multipliers or bladeless fans. They work really well as well, but you typically can get the same performance out of a much cheaper fan. So aesthetically, they look really cool. So if that's something that's important to you, then go right ahead. But if you are just looking for performance and value for money, there's probably more standard products that are going to get you there for a lower price. Then ceiling fans. So typically our DC ceiling fans will use less energy than our AC fans. A great way to compare different options is to look at the efficiency. So if we take the energy that a fan is drawing, or the wattage, and we compare it to the amount of air that's being moved by that fan, so the meters cubed per hour, we can get an idea of how efficient that fan is. So if we take the energy and we divide it by the amount of air being moved, then we're getting our watts per meter cubed per hour. And then we can use this figure to compare different fan models that are kind of different sizes and different airflows and wattages. And the lower that watts per meter cubed per hour is, then typically the more efficient that fan will be. So getting that number down as low as possible is best. And both the wattage and the airflow can typically be found on the brochure or the specification. So it's pretty easy to get a hold of if you're in the market for a new fan. And it can make a big difference. So some of the high efficiency ceiling fans draw as little as 12 watts, whereas your low efficiency alternatives can get up to 100 watts. So that's a pretty big difference. The other thing to consider is making sure that the ceiling fan you get is reversible. Most ceiling fans are, but it does make a difference in winter, where you can put the fan on reverse to push down any warm air that's accumulated at the ceiling level. So you're kind of getting to use the fan all year round, then getting some benefit out of it. Next, we have air source heat pumps, or our typical reverse cycle air conditioning. So with the outdoor unit that comes with a air source heat pump, during the summer, we really want that to be in the shade, because it's trying to reject heat from the home. So the cooler it is, the more efficiently it will work. But in winter, when we're trying to absorb heat and heat the home up from the outside, then we actually want it to be in the sun. So this is another good opportunity for some well-designed shading or some deciduous vegetation when we're thinking about the location of our outdoor unit with a reverse cycle air conditioner. So there's a few different types. There's the classic individual split system, which is one indoor unit for every outdoor unit. These are typically the kind of highest efficiency option. They're great because every space is individually controlled. So you're not heating up or cooling down the entire home. And so that generally results in them having a higher efficiency or coefficient of performance. Next option is multi-head splits. So these have multiple indoor units connected to a single outdoor unit. So these are typically a bit cheaper and more space efficient than the individual splits of equivalent size, but they are a little bit less energy efficient. So something to weigh up there. The individual splits typically use less energy and so have lower running costs. Then we have ducted systems, or our central systems. So this has a single indoor unit that's then ducted to multiple spaces. Again, this is typically less efficient than the individual splits, because often we're cooling down or heating up the whole home. Even with systems that do have a bit more zoning, they typically have a minimum kind of running speed. So they will do a larger portion of the home than a single room. Also, just having a ducted system inherently brings in some risks and inefficiencies. So our fan has to work a bit harder to push air through all of that ducting. So that's more energy being consumed. We also have heat loss or heat gain through the duct system in the ceiling. And there's also the possibility of air leakage. If the quality of the installation isn't top notch, then we can get some air leakage which is again going to reduce the efficiency of a centralized ducted system. For renters, we can always get a portable reverse cycle air conditioner, which is what's pictured there in the graphic on the right. So they're just self-contained little units that you can put in whatever room you happen to be occupying, and they typically come with a flexible duct to transfer hot air outdoors, and they often come with a fitting for a window so that it doesn't, you don't just have to have the window wide open as well, it'll block it out. Again, these aren't as efficient as some of our individual split options, but it's a good little alternative if you don't have a system built in and you are just renting. So next we have evaporative cooling. So this is usually the lowest energy option, other than fans obviously, in Melbourne. So it's only got a fan running and a little water pump. So it doesn't draw much energy compared to split systems or reverse cycle heat pumps. The only time this kind of changes is if we have a very efficient house or a very high quality thermal envelope of our house. So we've draft proofed it really well. It's got good quality insulation and good quality glazing, and we have a very high efficiency heat pump, then that's actually going to use less energy than evaporative cooling, because a heat pump is just going to recirculate air that's already inside the home. So if it's already been cooled down and the space is staying cool, it's really not going to use much energy at all. Whereas evaporative cooling brings in outside air all of the time and cools that down. So there is kind of a tipping point where an air source heat pump will become more efficient than evaporative cooling. But in most cases in Victoria, evaporative cooling is going to be a lower energy option. But there are a couple of other considerations. So you do require a constant water source to run evaporative cooling. So that has its own cost and environmental considerations. They're not super effective at higher humidities. This typically isn't a problem for Melbourne's climate in summer, but every now and then we do get those hot, muggy days, and the evaporative cooling is going to struggle a little bit. Again, we have all the associated problems with having a ducted system in terms of potential air leakage and heat losses through the ducting. Also, because evaporative cooling has to bring in outside air, if the damper that closes off when the evaporative cooling isn't running isn't perfectly sealed, we also get the risk of outside air infiltrating into the house when our evaporative cooling isn't running. So a few different things to consider, and obviously reverse cycle heat pumps will do our heating and our cooling. So often that can be the tipping point and make that the option to go for. With evap cooling, similar to the air source heat pumps, there are portable options available, which you can wheel around the house, depending on the room you're in, which is a good option for renters. So next on the list is our ground source heat pumps, or geothermal. These work a little bit differently to each other, but they both rely on the stable ground temperatures as we go deeper underground. These can get very, very high efficiencies, but usually this is outweighed by a very high price point and a lot of additional complexity. So while they can be good and a really interesting project if funds aren't really an issue, typically they're not the most practical solution compared to the ones we've discussed already. All right, so once we've looked at our cooling system and we've followed some of the other steps in the home energy retrofit journey, we can start to think about putting solar panels on the house. So the price of solar has been coming down steadily for years, which is great. The latest sources at the moment seem to indicate that a brand new 5 kilowatt system has a payback period of about 5 years, which isn't too long. And if we've applied a lot of the other passive principles, a 5 kilowatt system can even offset the energy that we're using in the home to make it energy neutral or even energy positive. And when Sustainable House Day comes around and we're allowed to kind of attend these kind of events, I definitely recommend having a look at some of the homes that are out there, as there's some very impressive examples of this where people in Melbourne have made energy positive homes, which is really cool. For renters, if you don't have a solar powered system, there's a few different power providers that have a green energy option so that your power is being sourced from 100% renewable options. So indoor air quality, as we discussed earlier, with increased risk of bushfire events or thunderstorm asthma, indoor air quality starts to become an important consideration for us. There are a few reasons why it should be important to us. There's a lot of research that indicates that there are negative health effects to being exposed to fine particulate matter, particularly at higher concentrations. I've cited a couple of stats there from different studies conducted in the US. So for every increase in the concentration of PM 2.5 particles of 10 micrograms per meters cubed, we also have an increase in all-cause mortality of 6 to 7%. So that's pretty serious for long-term exposure. There are also studies showing that short-term exposure increases mortality. So for every increase in concentration of 10 micrograms per meters cubed, there's been reported 0.6 to 1.5% increase in daily deaths. So can be pretty significant. And to put these kind of abstract numbers into a bit of perspective, I've got over on the right there the different limits of air quality concentrations for Victoria. This is pulled from the Victorian EPA. So if the concentration is less than 27 micrograms per cubic meter of PM 2.5 particles, then we consider that to be good air quality. If it gets over 370, then we consider it to be hazardous. During our January bushfire event this year, our concentrations peaked at over 400 micrograms per cubic meter. So when you look at that compared to the resultant effects on mortality, it's pretty serious and something that we should definitely consider. So what are the sources of indoor air pollution? Bushfire event is probably the biggest one, or if you live near people who have wood-fired heaters, then that can also be a source of air pollution in your area. Indoor cooking processes can cause increases in indoor air pollutants, or smoking indoors, or if you live near a busy road, vehicle exhaust. So these are the sources of air pollution we can be exposed to. So what can we do about it? Draft proofing is always a great option. Again, you're reducing the air change rate, so slowing down the rate at which outside air can infiltrate into the home. So if the pollution levels are higher outside than inside, then draft proofing should assist with that. Running your air conditioner. So this way we're recycling the air in home and running it through our filters. Typically the standard filters that come on your air conditioning systems probably aren't that great at removing smoke particles. But we'll talk about that a little bit more and what we can do about that. But certainly it's better than nothing, and just make sure you are replacing or cleaning the filters regularly so that they are still working properly. While you're cooking, always important to run the kitchen extract. I know some people don't like running it because it's a bit noisy and annoying, but it does help reduce buildup of particles coming off the cooking processes. And then our other options are portable air cleaners or an upgrade to our central air system filter. So we're going to dive a little deeper into these right now. So portable air cleaners, these are very effective and they can reduce indoor airborne particle concentrations by up to 85%, and in some cases even higher. Their health benefits and their effectiveness is very well documented. There's some very strong literature to support it. It's important to select one that has a HEPA filter, or a high efficiency particulate air filter. Most of the decent quality alternatives will come with this as a standard, but it is something to look out for to make sure you're getting the highest quality filtration you can get. And it's always important to select one that's suitable for the room you're planning on using it in. So typically they will specify a kind of maximum square meters. And if you can select one that's even bigger, like size for a larger room than the one you're using it in, then the more effective it will be. Something to consider is the hours that we use it will limit its effectiveness. So the longer we're running it and the higher the fan speed, the better it's going to filter the air. So typically while the room is occupied, if there is high pollution or poor air quality, then you should run it the whole time that you're in the room rather than turning it on briefly. One downside is they can be a little bit noisy, and obviously it is a cost to purchase one of these. So things to consider. The next item is upgrading the filter on our central air system. So most home systems use a pretty low performance filter. The EPA, this is the US EPA, has a lot of recommendations around this for bushfire events, and they recommend a filter with a performance rating of F6 or F7, which is a bit better than typically what a normal air conditioner will come with. And this will filter out more smoke. You can look at putting an even more highly rated filter in, like a HEPA filter, which is what we talked about earlier. So F6 and F7 won't filter as well as a HEPA filter, but it can impact on the performance of your central system. If the filter is too highly rated, your system might struggle to push air throughout the house if it's a central system. So you might want to get in touch with the manufacturer if you really want to take it further. But that F6, F7 rate is kind of a happy medium that should filter a lot more pollutants without ruining the performance of your central system. Again, operating hours will limit the effectiveness, and there isn't as much research on the effectiveness of upgrading the central air system filters and the health benefits that come along with that. But Logically, it does make sense that if we're filtering out more pollutants with our central system, we should see some benefit there, but it just doesn't have the same body of literature to support it like the portable air filtration unit. So what can renters do? There are some new regulations being released in March next year. Basically, these will allow renters to make further modifications to the home without the permission of the landlord, or at least with the permission of the landlord, but there will be restrictions around what a landlord could reasonably refuse to allow in terms of upgrading the home. And ideally, this will also allow simple energy efficiency upgrades in the home, things like draft proofing or other minor options. So just something to look out for next year if you are a renter and you would like to make changes to the home and you want to know what's allowed, there should be some new regulations on the way. All right, so that's pretty much it for the main bulk of the presentation. I did just want to share a couple of tips and tricks that we found over the years. I've got a little trick you could even try out today to actually try to find the worst sources of draft or air leakage in your home. So if you go around the home and you switch on all of your extractor fans, so the kitchen exhaust hood and the bathroom fan and everything, and you seal up the home, shut up all the doors and windows, then this air that's being sucked out of the house has to be made up from somewhere. And so we can use this to try to find where that air is coming in. So often you can feel air coming in around doors, windows, or floorboards, and actually use this to go around the home trying to find the worst sources of air leakage. If the house is really big or really drafty, or the fan's like very strong, sometimes it doesn't work that well. But often, we've found more often than not, it is effective in trying to actually locate some of the drafts in the house, which is a pretty cool little exercise. I think it's fun. Anyway, you can switch all the fans on and go around feeling for drafts. Then a few different items to look out for. Doors and windows are a fairly obvious one. A less obvious one is plumbing fittings. Often these aren't sealed up properly and can have a lot of air leakage. Also, extractor fans, when they aren't running, is just a big hole into the ceiling space, which is a big source of draft, and I'll come back to this one in a sec. Same with fireplaces and chimneys. If you've got one of these in the home, these are a big source of air leakage. Evaporative cooling vents, we already touched on a little bit, but when the evaporative cooling isn't running, we can get some air leakage through these. Old style permanent wall vents, often these are just a few kind of slots in the wall, or sometimes they're a bit more decorative, but these can be an unwanted source of air leakage, and typically they're a relic that's kind of left over from open fireplaces or kerosene heaters where that risk of asphyxiation was there. But in modern homes with kind of closed flue gas heaters or other types of heating, then we really don't need these permanent wall vents to be there. Skirting is a good place to look. Ducted heating vents as well. So if you take the cover off your ducted heating vent, 9 times out of 10, in our experience anyway, you can see straight through to the dirt below the home. So that's one to look out for. Gaps in the floorboards, and also unused power outlets. So if you've got a power outlet that you hardly ever use, that's just 3 little holes into your wall space, which is an unconditioned space where we don't want air movement between the wall and the conditioned area. So often you can just put the little safety covers, plug one into an unused power outlet, and you've just solved a little minor source of draft. So I thought I'll just double back to extractor fans and fireplaces or chimneys, because there's a couple of cool options out there that people may not be aware of. So I will just stop sharing for a sec so my camera gets nice and big for people, but you can get a product that, just got stuck on something else. Looks like this. So this is a draft stopper. It's got a couple of flaps on top which open up like that. So this actually goes in your ceiling space over the top of an extractor fan that discharges direct into the ceiling. So maybe the toilet or the shower fan. When the fan is running, the airflow from the fan will lift these flaps up and it can operate normally. And then when the fan switches off, they fall back down to seal off the ceiling space from the home. There's a little graphic that perhaps shows it a little bit more clearly on the packaging. But yeah, so they just sit in the ceiling space and are a good source of draft proofing for an extractor fan. The only issues you might run into if it's a very old fan or not a very strong one, sometimes they struggle to even lift these very light plastic flaps up, so it won't work. Or for the built up kind of bathroom units with the lighting in it as well and the heat lamps, sometimes they don't really work well because they look a little bit different in the ceiling space. It doesn't just fit neatly over the top. So that's a cool little trick for extractor fans that I thought I'd share. The other one is for fireplaces and chimneys. So often when we started, we'd use these chimney balloons, which aren't a bad product, and they're still pretty common. The issue, or the way these work, is you put the balloon up into the throat of the chimney and inflate it, and then the pressure from inflating it holds it there while also stopping air movement through that chimney from outside to inside or vice versa. The issues we found is they would either leak a bit of air over time and fall out, or if it got cold, the pressure inside the balloon would decrease and it would shrink and also drop out. So not a bad product, but often needs to be topped up and can be a little bit difficult. So since then, we've moved on to using just a big slab of medium density rubber foam, and you can just cut this a little bit wider than the throat of the chimney and then push it up inside there, and then that'll block it really nicely and stay in there nice and snug regardless of the temperature. If you're a renter as well, you can pull it out before you leave, so they're removable. So yeah, that's typically what we recommend for a fireplace or a chimney that you aren't using, is one of these. You can get them from EcoMaster, or you can just buy some medium density rubber foam from Clark Rubber to size. So that's a couple of little tips and tricks I thought I would share. And that more or less concludes the presentation and takes us over to some Q&A if people have some questions.
Yeah, awesome. I've got a bit of an echo. I'm just going to check some mutes. I think that should be better now. Yeah, we've got about 10 minutes with Arky now for Q&A. So there's been a few questions that have come through that I might start with, but otherwise just pop your questions in the chat and we'll throw them to Arky. He's a great resource and brain to have across all of your queries today. So it's a really good opportunity. The few that have come through so far throughout the session, Arky, Sharon has blown in paper insulation from when the GFC happened. Does she need to look at that insulation? And someone else had a similar situation. Is that still safe?
In terms of as a fire hazard, I possibly don't have the expertise to comment on that as a kind of fire hazard or a code compliance issue. Yeah, hopefully if it was done properly, I think they treat the paper so that it's non-flammable or at least flame retardant, and then they can use it as an insulator. So if it was installed properly with a good product, it can be safe. But yeah, in terms of it being a fire risk, I think that's a little bit different to some other products we see on the market today. So I'm not totally sure. But if you are worried about it, I would definitely see if you can get in touch with the supplier or the installer to look at that.
Yeah, I'll do some research online. There's a really great group that some of you may know of. It's a Facebook group called My Efficient Electric Home that has, I think, over 20,000 members. And it's a really great resource for asking all sorts of questions as you kind of go on the journey towards reducing energy use and becoming electric. So there's, yeah, some great brains in that group that can answer questions you might have. But yeah, we definitely recommend some research in that space. Sarah asked about retrofitting apartments with flat roofs, with a flat roof without access. I think that one was in relation to insulation, but Sarah, correct me if I'm wrong.
Yeah, possibly insulation or maybe the extractor fan item as well, because we don't have ceiling access. If you don't have ceiling access, then you won't be able to install the extractor fan covers. So that's just a bit of an unfortunate reality. You do need to be able to get inside the ceiling to install them. If you've got someone who can get on the roof, maybe if it's a kind of tiled roof or got removable roof panels, you could get into the ceiling that way. So getting a little bit more effort and perhaps a little bit outside the DIY range and more into getting someone in to install it. But yeah, definitely it does make it a bit harder if you can't access it from underneath. If you are considering insulation, then a lack of roof access adds a layer of complexity, but shouldn't be a deal breaker. Again, if you're already paying for the process of getting all of the extra insulation put into the ceiling, then typically they'll get plumbers or whoever to be able to seal up the roof afterwards or get on the roof and get that installed properly. So shouldn't be a huge barrier for getting insulation installed, but yeah, it can make it a bit tricky to get those little extractor fan covers in.
Cool. There's quite a few questions coming in, so we'll try and get through as many of them as we can.
Okay.
There's a few asking for names of brands and installers and that kind of thing for
Sure.
air conditioners and insulation and that kind of thing. I'd probably recommend taking a look at Renew, which is a really great online not-for-profit kind of web platform that has heaps of really good information and buying guides. So I'll send a link through after this. Arky, did you have thoughts on that as well?
I don't have specific brands that I would champion for different active cooling systems. I'll definitely encourage you to do some research and to visit resources like that. Certainly, Choice is another one that I use sometimes for comparing different options, and they'll look at it very holistically in terms of energy efficiency and performance and upfront costs. So that's another good resource for comparison. In terms of really high quality insulation with experienced installers, we've actually partnered up with EnviroFlex, and so I can definitely recommend them. And if you are interested in insulation, you can get in touch either with me and I'll organize that, or with them directly. But they're a really reputable company for installing good quality insulation following the kind of thermal principles that we spoke about, like good insulation coverage and no thermal bridging. But yeah, in terms of reverse cycle air conditioners or evaporative cooling, I'll just encourage you to go out and do a little bit of research, because all the brands also have a range of different energy efficiencies and coefficients of performance. So it ultimately comes down to individual products, and there you need to just do a little bit of homework and see what you can find.
Yeah, and again, that My Efficient Electric Home Facebook group has lots of kind of great responses to people asking questions for brand recommendations as well. All right, is there a way to retrofit insulation into a cathedral ceiling?
The cathedral ceiling. Okay, so the roof is exposed. Do we mean by that? There's no actual kind of like ceiling cavity?
Wendy, you might have to specify. Maybe we'll move, if you just pop that in the chat, Wendy, and we'll move on to another one, which was, can you paint over air vents? Does that stop the airflow?
So we're talking about like the permanent wall vents.
Yeah.
Yeah, if you fill it right up with paint and you can see that it's blocked that gap, then absolutely, job done. You might want to put in a bit of gyprock first if you want a smooth finish. So often what we typically do is we'll just get a bit of gyprock and we'll scrape it into the existing permanent wall vents, and then you can sand it smooth and paint over the top of it. And we'll even often we'll get a bit of gap filler rod. So we'll get some of this gap filler rod. You can just get it from Bunnings, and we'll push it inside the slots of the wall vents, and then that just gives the gyprock something to kind of grip onto a little bit, and we just do a nice smooth layer over the top with gyprock. And that's an easy way to do it. But yeah, if you're happy to just fill it up with paint and you don't mind the look of the slots in the wall filled in with paint, then that's definitely going to stop the air from moving through.
What about for renters, Arky, that can't paint?
Yeah, so for renters, you could pop some of the gap filler rod in, because then you can just pull it out again. So this is really easy to remove, and we'll block it up. Probably would talk to the landlord if we're getting into gyprocking and painting. But yeah, this can be a nice temporary solution, something you can pull out. Whereas yeah, probably would shy away from permanently closing up any holes in the wall without speaking with my landlord first.
And Wendy's come back, hers is a cathedral ceiling with no roof space and a tiled roof.
Yeah, okay. That's an interesting one. I have to admit, I haven't put a lot of thought into this alternative previously, but I don't see why. There's definitely a way to install insulation. I guess the bats would be pushed right up against the ceiling, and I guess against the roof, instead of typically sitting on top of the ceiling. So maybe one to talk to different insulation providers about, or I'd be happy to speak with EnviroFlex and put them in touch with you if you want to get in touch with me. But yeah, I think there will be options out there. It's not a problem I've encountered yet, so that's a new one, but I imagine there are definitely ways to put on some panel insulation onto the actual roof itself. On the inside, it would be.
All right, we'll throw to Nadine's question, which is a really great one. Any thoughts on having conversations with landlords, property managers about splitting costs on things that may improve property value but mean energy savings to renters, for example, solar.
Yeah, I think absolutely you should start that conversation, and more renters should be having that conversation with their landlords to try to upgrade the stock of permanent rental homes out there, which often don't get the same love and attention as owner-occupier homes. In terms of tips in having that conversation, I guess just have a reasonable approach and see how you go and raise it. There's a few things I've done on this house which I just paid for myself, like putting some seals around the front door and along the bottom of the door and a couple of windows. But yeah, definitely if it's something as significant as solar power, get in touch with the landlord and see if they have an appetite for that kind of thing. And obviously it is an improvement to their home that will last long after you leave it. So I would certainly think there should be some kind of cost sharing there. If not, they should probably pay for the whole thing if it's solar panels, but maybe it would adjust your rental price because the home is worth more to live in and has reduced running costs. So that could be one way to look at it, where they pay the initial upfront cost and you pay a little bit more in rent that's offset by reduced energy bills.
And I'd probably also recommend having some stats and some data from research that you've done to take to them when having those conversations, just so that you're feeling really informed yourself and you've kind of built a little case. And there's lots of places you can seek that information, like that Facebook group I mentioned, Renew Australia, and also the Australian Energy Foundation. And I'll send links to all of those websites following this as well. We probably can squeeze in maybe a couple more questions. There's a few great easy draft proofing ones. Elle has small slip vents near the roof. Do you have any tips for covering them up, especially for renters?
The little slip vents near the roof. I think perhaps that's what we were talking about with using the chip rock to cover them up. Yeah. For renters, again, maybe just put in some gap filler rod. It comes in different sizes depending on how big the slats are, and it's really cheap. You can get it from Bunnings and push them in. The other option as well that's out there is you can get these little wall vent sealers from Bunnings. They come in a packet like that, and they just look like this. They've got a couple of little nubs on the back and also 2 adhesive strips. And so you can just put that into the top slot and push it onto the wall. And then that'll seal the existing kind of vents in the wall nicely. It doesn't seal as well as actually filling it in with chip rock and gap filler rods. I don't know why, but for some reason they don't have an adhesive strip on the bottom, and it always sits out like a mil or less. But so it's not a perfect seal, but certainly an improvement on what's there. Maybe again, not the best one for renters because the adhesive strip might damage the paint if you did want to remove them later. But it is another option, probably more for the homeowners. But for renters, I think just stuff in some of the gap filler rod, buy it a little bit bigger than the slats or the slots so that the compression will hold it in there. And if you're a homeowner, you can take it further and cover it up permanently, or look at some of these quick and easy options from Bunnings.
Thanks, Arky. We've just ticked over to 1 o'clock, so I'm very conscious of time, and I think we'll leave the questions right there. And I'll just close us out by saying a huge thanks to Arky for coming along today and spending lunchtime with us and giving us really so many ways that we can get started and improve the performance of our home, and in turn, reduce our carbon footprint, but also maybe reduce the energy bill and make our homes more comfortable along the way. So yeah, hopefully you guys have come away with lots of great ideas, and I'd love for you to just share in the chat window before you go something that you're taking away with you that maybe you might be implementing over the next few weeks at home. I'm really keen to see that as you head on out. But yeah, thanks so much for coming along. I'll send a follow-up email with a whole bunch of resources and Arky's details as well, should you wish to contact him. And we've had a great suggestion from someone to run a session similar to this, but with a real focus on DIY improvements for renters and particularly low income. And I think that's really great. And we're always running a whole bunch of events at Sonington. So if you're not already subscribed to our environmental newsletter, please do. It's a really great one that comes out every month, and we put a whole bunch of events on, so you can find out about them. But yeah, hopefully we'll see you at another environmental event soon. and hopefully you're all ready to get stuck in the couple of weeks we've got before summer and before it really starts to heat up. Thanks for coming along today, folks.
Thanks so much, everyone. Hope you got something out of it.